So in this session, we will discuss speed time and distance time graphs as well as the questions related to distance time and speed time graph. In the first question, a driving instructor gives a student a sudden order to stop the car for a shortest time possible. So there's a driving instructor and he told the student to stop the car in a shortest time possible. Figure 1.1 shows the speed time graph of motion of the car for the moment the order is given. So this is a graph which is showing the speed time graph when the order is given. So for some time, what happened, like example, the car continued to move with a constant speed, as you can see in this part, even though the order is given, but the car continued to move with a constant speed, and then the car slowed down and eventually the car stops. So what might be a reason why the car continued to move with a constant speed for some time? And here the car slow down or decelerate the moment the student applies the brake. So what is the reason why the car does continue to move with a constant speed for some time? Because like that's called a reaction time. For example, if you're driving a car and someone give you an order that stop the car, so when he is giving you an order, stop the car, so you will take some time to react to the instruction. So when you are taking some time to react to this instruction and you will not press the brake instantly, so the car will continue to move with that same speed or constant speed. So that is due to the reaction time. So why, even though the instructor give the instruction to student that stop the car, but student continue to move with a constant speed and then the car stops or slow down and stops. The reason was that because when the instructor give the instruction to the student that stop the car, then student will take time to react to the instruction or order. So that is called a reaction time. Like if someone is saying, giving you an order, instantly you do not perform that action or work. You will take some time to react to the order, and that interval is known as the reaction time. So the first part, the order to stop the car is given when time is equals to 0. So when time is equals to 0, instructor order the student to stop the car. State the speed of the car when time t is equals to 0. So what is the speed of the car the moment when the instructor order the student to stop the car? So what is the speed? So that speed, you can, each box is equals to 1. You can count like 1, 2, 3, 4. So there are 10 boxes equal to 10. Each box is equal to 1. So there are 8 boxes above 10. So this number is 18. So what is the speed of the car the moment when the instructor ordered the student to stop? So that is equals to 18 meter per second. Then suggests why the car continue to travel at this speed for 0.9 second. So why the car continue to move with a constant speed even though the instructor gave the order that stop the car, but student did not stop the car instantly. First it will move for a short time, 0.9 second for constant speed, and then it start to slow down. So what is the reason why instantly the student was not able to stop the car? So that is the reaction time, or due to the reaction time, because instantly whenever someone is giving you an order, you don't perform that action, you take some time to react, and that time interval is called a reaction time. So same thing, the moment instructor ordered the student to stop the car, the student will take time to react to the instruction, and then he will press the brake. So in that interval when he was reacting, that interval is known as the reaction time. Is it clear? Part A, part 2. Is it clear to everyone? The second part as well. Then calculate the deceleration from 0.9 to 4 seconds. If we are calculating a deceleration, because it's a straight line graph, so whenever straight line graph is there, how to calculate acceleration or deceleration, you will use a formula as we discussed yesterday, that acceleration or deceleration is a change in velocity divided by time. So what is the final velocity, how we can work out, and what is the initial velocity when time is equals to 0.9 second, that is the initial velocity. So what is the value of initial velocity, or u? So at this moment the speed is 18 meter per second. And what is the value of the final velocity? Because the car stops, so the final velocity is 0. And what about the time interval? So time interval is from 0.9 to 4 seconds. So 0.9 to 4 seconds. That time interval is known as 3.1. From 0.9, because it is from starting from 0.9 and ending at 4. So the time interval from 0.9 to 4, that is equals to 3.1 second. So when we substitute, the final is 0, the starting speed is equals to 18, and the time interval, that is 3.1. So minus 18 divided by 3.1. So it will give us minus 5.8 meter per second square. It is 18 divided by 3.1. So it is 5.8 meter per second square. The next part, the total distance traveled by the car from t is equals to 0. So from the starting to the end, what is the distance traveled by the car? So for a speed time graph, if we are calculating a distance, so what we can do, we can use area under the graph. And what about in this example, area under the graph? So it's a trapezium, so you can use a trapezium. The sum of the formula for trapezium, sum of the parallel sides, like a plus b multiplied by h, and that is divided by 2. So a and b are the parallel sides. So one of them you're saying a, another one is b, and the difference between them is called h. So this is a, b, and h. So what is the value of a? It is starting from 0 and ending at 0.9. So a is equals to 0.9. What about b? It is starting from 0 and ending at 4. So b is equals to 4. And what about height? The difference between them, that's equal to 18. So we have the formula, sum of the parallels, half sum of the parallel side into height. So one of the parallel side is 0.9 plus 1 plus 4 multiplied by the difference between them, that is 18, divided by 2. So when we solve, it will come out as 44 meter, or 44.1. It is round, that's right, Abdullah Sarfraz, 44.1, or it is rounded off to 44, but the calculated value will come out as 44.1. So if you write this 44.1, that's also a right answer, because you always write your answer in 3 significant figures. Is it clear, this question? To everyone? Okay, moving on. to the next question. So in this question, figure 1.1 shows the axis used to plot a distance time graph. On a figure 1.1, draw the graph for an object moving at a constant speed. So I want everyone to use the screen annotation to draw the graph for a distance time graph at a constant speed. Distance time graph for an object moving at a constant speed, and label that graph as A. You can use the screen annotation to complete this part. Yeah, that's right. So when we have a distance time graph for an object moving at a constant speed, it will be a straight line. And what about the second one? Yeah, for moving with the decreasing speed, label that as graph B. So if a speed is decreasing, so slope will decrease. And so when you complete this, the first answer, this will be A, which is a straight line. Constant gradient shows speed is constant. And you don't have to start from end of A, you have to start again from origin. That B shows that the speed is decreasing, so the slope should decrease. Another similar question, but this time you have a speed time graph. Speed time graph, you have to draw a graph, so use the screen annotation and complete this graph for an object moving at a constant acceleration and label that as S. Speed time graph for constant acceleration. If it is a horizontal line, it means zero acceleration. Because if speed is not changing, whenever we draw a horizontal line, this is not the right answer. Why? Because this shows that the speed is constant and acceleration is zero. So there should be a straight line with a constant gradient. This shows that it is a constant acceleration and label that as S. And there is another graph which you have to plot for an object moving with increasing acceleration and label that as T. If acceleration is increasing, so if acceleration is increasing, the slope should increase and we label that as T. This is showing that acceleration is decreasing because the slope is decreasing. So when it's a speed time graph for constant acceleration, it will be a straight line, and for increasing acceleration, the slope should increase. When you are drawing a horizontal line, what this horizontal line shows, if you draw the horizontal line, it shows that the speed is constant or acceleration is zero. That is for speed time graph, because if speed does not change, means the acceleration will be zero. Next question is about acceleration and completing a graph. So first thing, define acceleration. So how we define acceleration? It is change in the velocity per unit time. So how much or rate of change of velocity you can also say, or what is the change in a velocity in a unit time you can say, or even you can write a formula that it is v minus u divided by t. So any one of them score mark. As you can see, rate of change of velocity or change in velocity divided by time or change in velocity, or even you can write a formula. Now the second type of questions related to this topic is about completing a graph. So first time, for one type of question is they will give you a graph and you have to do a calculation from the graph. The second one, you have to complete a graph from the information which is given. So in the question, figure 1.1 shows a speed time axis is for graph of the motion of the car. The car starts from rest, so car is at rest. So if something starts from rest, it will be at zero, because the speed should be zero when something is at rest. So for time t is equals to 0 to t is equals to 15, the car has a constant acceleration to a speed of 28 meter per second. So what they mean, from 0 to 15 second, the car will move with a constant acceleration and it reach the speed of 28 meter per second. So first I will find when time is equals to 15. This is 11, 12, 13, 14 and 15. So this is the time interval 15. And what about speed 28? Each box is 1, so 21, 2, 3, 4, 5, 6, 7 and 8. So this one is 28. So they mention that car continue to move with a constant acceleration. So if it's a constant acceleration, I should draw a straight line. And what should be the position of this straight line? It should reach a speed 28 meter per second when time is equals to 15. Is it clear, the first part? From time is equals to 0 to 15 second, the car is having a constant acceleration and it reaches a speed of 28 meter per second. Then the second part, for time 15 second to 32 second, the car has a constant speed of 28. So what does it mean? The car does not change its speed. The term constant speed means speed does not change. So from 15 seconds to 32 seconds, we have to draw a constant speed. Constant speed means a horizontal line in a speed time graph. So when time is equals to 32, so this is the time, it's 32. And it continue to move. So I will draw a horizontal line which shows that the speed does not change until 32 seconds. Then the third part, for time 32 seconds, the car has a constant deceleration of 2 meter per second square until it comes to rest. So the car is having a deceleration of 2 meter per second square until it comes to rest or until it stop. We have to complete. So basically, when something is decelerating and stop, we'll draw a line like this. But one more thing, what we have to do, we have to find a time, how much time it will take to stop, because I cannot complete a graph without because this is also a car is decelerating, this car is also decelerating, so all the options are decelerating, but I don't know how much time it will take to decelerate. So for that, I have to first calculate the time it will take to completely stop. So we have the formula for acceleration, which is v minus u divided by t. So acceleration or deceleration is 2. Final velocity, what is the final velocity? That is 0. Why 0? Because they mentioned it is stops. So final velocity is 0. And what about the starting velocity? Because the car was moving with a velocity of 28 meter per second. So initial velocity will be 28 divided by time. And because it is deceleration, so when we work out the time, so it will come out minus 28. When I solve this part, this 2 is equals to minus 28 divided by t, or if I cross multiply, so 2t is equals to minus 28, but I need t, so t is equals to minus 28 divided by 2, so it will come out as minus 14. Minus 14 or 14 seconds. So basically this car will take 14 seconds. Why we are getting a negative answer? Because the car was decelerating, that's why we are getting a negative answer. But the number is important, so it means this car took 14 seconds because the time of minus 14 does not make sense. How it is 2t? Look, Abdullah, the deceleration is 2, the final velocity is 0, the initial velocity is 28, and time is t. So 0 minus 28 is equals to minus 28. This t is divided here. So in a mathematics, if one side of equal to, if value is divided, the other side it will be multiplied. That's why this t is divided, other side it will be multiplied. So it will become 2t is equals to minus 28. But because we are finding t, so 2 is multiplied, other side it will divide. So minus 28 divided by 2, that will come out as 14. So it will take 14 seconds basically to stop the car when it was, so from 32 plus 14, that will make 46. So what we have to do at 46 seconds, 41, 2, 3, 4, 5, 6. So this is 46. And then we have to draw, because it's a constant deceleration, so it will be a straight line. So at 46 seconds, this car will stop. Is it clear, this question? That how we complete a speed time graph for motion of this car, which was first having a constant acceleration, then here time is 14 seconds. So what does it mean? It means that it will take 14 seconds to stop. So car at this moment, when it was moving with a constant speed, at this moment it is already 32 seconds. So after 32 seconds, this car, which was moving with a speed of 28 meter per second, will take 14 extra second to stop. So 32 plus 14 extra second. So it means at which moment or which time interval it will stop completely. So it will stop completely at 46 second. That's why we draw a line at 46 second where the speed is 0. Is it clear, discussion? Okay, moving on to another question. So it's a distance time graph, and I told you when distance time graph is there, we normally use the term speed and acceleration. So in the question, the first part, describe the motion of the cyclist. This is a graph, a distance time graph for journey of a cyclist. Describe the motion of the cyclist in the time between 0 and 15 seconds. So 0 and 15 seconds, what is happening to the motion from 0 second to 15 second? This part. What is happening to the speed of, so speed is increasing or it is accelerating, that's right. Then when time is equals to 15 seconds to 30, so from 15 second to 30 second, what is happening? It's a straight line for a distance time graph. So when it's a straight line for a distance time graph, it shows that the speed is constant or speed is not changing, or you can say it is a uniform speed. And from 30 seconds to 40 seconds, from 30 seconds to 40, what is happening? The slope is decreasing for a distance time graph, so it is decelerating or it is slowing down. The next part, yeah, that's right. The next part, calculate for 40 seconds average speed. So how to get an average speed? The term average speed is equals to total distance divided by total time. So the total distance traveled by this cyclist is 300 meters. That's a complete distance. And the total time to complete the journey, that's equal to 40 seconds. So when we calculate the average speed, the total distance over total time, so total distance is equals to 300 and the total time is 40. So 300 divided by 40, that's equal to 7.5 meter per second. The next part, we need a maximum speed. Now, as this graph is having different sections, if I label the sections, like example, if I say this is the red part is section A to B, then the second part is section B to C, and the third part is representing a section from C to D. So which section is having the highest speed? Because the speed is refers to slope. So which section is having the highest or the maximum speed? Is it AB, BC or CD? So which is having a steeper slope? So it is from B to C, because not in a region. So in this region from B to C, it is having the maximum slope. So using this B to C, we will find the speed from B to C. And how we'll work out the speed from B to C? So we'll find the distance travel from B to C. So at point B, it is at 70 mark. At point C, it is 250 mark. And the time from B to C, at B it was 15 and C it is 30. So moving from B to C, the distance traveled from B to C, because it will be 250 minus 70, which is equals to 180. And the time interval from 15 second to 30 second, the time interval is 15. So 180 divided by 15, what we'll get? The maximum speed will come out as 12 meter per second. Is it clear, this question? Finding the speed of a maximum speed of an object using a distance time graph. So we check the region where it is having a steeper slope, and using that region we can work out the maximum speed. Okay, another question. In the question, a rocket is launched vertically upward from a ground. The rocket travel with a uniform acceleration from rest. So the rocket start from rest. So if something start from rest, the starting speed is 0. After 8 seconds, the speed of the rocket is 120. So that is a final speed which is 120. So V is equals to 120. And how much time it took to change the speed? That's equal to 8 seconds. We have to calculate the acceleration of this rocket. So the acceleration of this rocket, acceleration is change in the velocity divided by time. So it is V minus U divided by T. V is the final speed, which is 120. U is the initial speed, that is 0. And the time interval, it took 8 seconds. So 120 minus 0 divided by 8. So that is equals to 15 meter per second square, the acceleration of this rocket. On the figure 1.1, draw a speed time graph for the motion of a rocket for first 8 seconds. So how we can draw a speed time graph for motion of the rocket for first 8 seconds? First dimension, it is moving with a constant speed, so it should be a straight line with a constant slope. And at 8 seconds, here each box is two boxes representing 1. So this is 6 and this one is 6. 7, and this is 8. So when time is equals to 8, when time is equals to 8, what is the speed of the rocket? Speed of rocket is 120. And each box on x-axis is representing 5, because from 0 to 50, there are 10 boxes, so each box is representing 5. So this will be 105, 110, 115, and 120. So this will be 120. So when the time is 8, the speed is 120. So it will be a straight line with a constant slope. So we completed this part of a graph, that for first 8 seconds the rocket was having a constant acceleration. Then use the graph to determine the height. Basically, height is the distance. What happened? As the rocket is launched vertically upward, so distance traveled by the rocket, the vertical distance traveled by the rocket is equals to height which the rocket reach. So for a speed time graph, how we can work out the distance travel or the height? So we will take area under the graph. So when I close this figure, so what shape it will form? It will form a triangle. And what is the area of the triangle? Area of the triangle is half base multiplied by height. So what is the base here for the rocket? Base is 8. This is a base. And what about the height? Height of the triangle, not height of the rocket. The height of the triangle in this example is 120. So that is multiplied by 120. So half 120, 8 into 120, that will give us 480 meters. So this is the distance traveled by the rocket, which is equals to 480. And whenever you write the answer, always write the units. That is, if speed time graph is in meter per second, distance is in meter. If it was in centimeter per second, the distance will be in centimeter. Is it clear? Part 2, B1 and 2 to everyone? Okay, the next part, for time t is equals to 8 second to 20 second, the rocket rises with increasing speed but decreasing acceleration. Is increasing, the speed is increasing but the acceleration is decreasing from 8 seconds to 20 seconds. So the speed is increasing but the decrease in acceleration. So when acceleration is decreasing, how we complete a graph? We reduces the slope. I will complete the graph as well, but explaining the idea, when it's a speed time graph, if acceleration is decreasing, we should draw a slope or decrease in gradient. Then for time 20 second to 25 second, the rocket has a constant speed of 200 meter per second. On a figure, draw a graph for draw on a figure 1.1, draw the graph for this motion. So from 20 second, from 8 second to 20 second, we have to show that decrease in acceleration until what speed, as you read the second statement, that it reaches a speed of 200 meter per second. So at 20 second, it should have a speed of 200 meter per second. And then it will continue to move with a constant speed. So constant speed means it will be a straight line. So what about this section? How I will complete this section? In this section, I have to show that acceleration is decreasing. And how I can show acceleration is decreasing? So to represent that the acceleration is decreasing, first it was a constant gradient here, and then there's a decrease in acceleration. So we will join the points. but we should continue to decrease the slope until it reaches a constant speed. Is it clear, this part? So the first was a constant, this was constant acceleration. In the first part, it was constant acceleration. This part decreasing acceleration, and this part zero acceleration or constant speed. In this part, at t is equals to 35 seconds, an airplane stopped decelerating and move along the runway at a constant speed of 6 meter per second for further 15 seconds. On a figure is sketch the shape of a graph for a distance time by an airplane along the runway for 0 to 150 seconds. So first, at t is equals to 35, airplane stop decelerating. So in this part, distance time graph, till this part, what we have to show? We have to show a deceleration. And this part, for 15 seconds, we have to show a constant speed. So how we represent a deceleration for a distance time graph? We'll represent by a curve, that's right. So distance time graph, it will be a curve, and then it move with a constant speed, so it will be a straight line. This is a distance time graph. A distance time graph, when the slope decrease, that is representing a decelerating or decrease in speed. This is not the speed time graph, Abdullah. This is a distance time graph. So distance time graph, when the slope is decreasing, it means the speed is decreasing, and speed decrease, we call that as deceleration. Is it clear to everyone? This example. So I'll share another link and continue this discussion.